And one more function that I'm just going to do so we're just pretty comfortable with working with linked lists. We're going to print a linked list in the following format, okay? And notice we also have a space at the end. It's a little small thing, but that's something it just makes the function definition easier. But anyway, so what we want to do is so I'm going to just do this. I'm going to do this one iteratively. You should be pretty comfortable doing iterative and recursive linked list processing, but I strongly encourage that you focus on recursion as well, because that's, I think, the more natural way to work with linked lists. Although I'm biased, I just love recursion. But anyway, let's look at how we can do this. So we can first define an initial string as nothing, and well, also notice that the print link on link.empty doesn't do anything. So we have to also take care of that case. If the link is link.empty, we have to basically then, we need to just stop. So how do we stop a function? We return something. And in this case, we're going to return nothing because we don't want anything to display. So we're just going to return. And then we're going to basically build a string from nothing to something. Okay. So what we can do is we can do s is equal to s. So while it's the case that my link is not the link.empty, what I'm going to do is I'm going to basically build s up by taking the string version of my link.firstElement and adding a space at the end. Okay? So the reason this is, this is basically going to build this one space, the element space idea. So we're going to take an element each time and just concatenate it with that string so far. And then, of course, to prevent an infinite loop, we have to basically make our way to the condition by doing link is equal to link.rest. This is a very important line in any iterative version of linked list, because we're going to find a way to progress our way through the linked list. Because if we don't have this line, the link is never going to be the link.empty, and we'll have an infinite loop. And then at the end, once I've built my string, I just print the string, because we're printing the linked list version. Okay, so let's do a doc test on this, and it works. Okay, now that we're pretty comfortable with working with linked lists, remember what our goal was building this linked list class. So we haven't quite achieved it yet. We've built length functions and we've built get functions, but this doesn't actually allow for indexing. So just in case you're not convinced about that, let's look to make sure that it actually doesn't work. So if we interactively run this and we define a linked list, so I'm going to define a linked list, I can't really index into elements. So if I get link of 2, I should get 3, but that doesn't work because it does not support indexing. Okay? And I also can't do length of the link because has no length. So what this basically says is these objects don't support these type of operations. So how do we do that? Well, there's actually a pretty easy way to do that. And it's similar to the way we worked with repr. So if I want to have a built-in length idea inside this class, I can just override the built-in length method. Okay, and so the length just takes itself, and then what we can do is we can basically take the same recursive definition and copy it. So actually, in this case, I'm going to make it a little simpler because there's also one important idea that we haven't thought about. The empty linked list is actually a tuple, and a tuple has a notion of length. So what we can do is we can just return 1 plus the length of the link.rest. Oh, sorry, not link.rest, self.rest. So when I call this length function, it automatically calls this function. So it'll first see where it can get this type of definition, and it'll call it. So it was the same idea with repr, if you remember. So, and then for indexing, turns out that whenever so let me just show you something cool. So if we do list 1, 2, 3, we can get the second index by doing this, right? But we can also get the second index by using a special method called getItem. So, and actually it turns out that whenever we use indexing of a list, it secretly calls this method, and we get 3. So what we basically have to do to support indexing is we just have to override the getItem method. So this will take in an argument of an index, And what we can do is we basically copy our get method. So if the index is 0, then we basically return self.first, right? And then if it's not 0, we return, basically we can take self.rest, so that's our linked list, and we can index into I minus 1. So the reason this indexing operation is going to be recursive is because indexing secretly calls get item. So let's make this work now. So let's see if we can define our linked list. So hold on. So we have a link, and then link of 2 now gives us 3. Length of linked list also gives us 3. So this works. Okay. Now, what if I want to find a way to represent my linked list? That's our last goal with this linked list class. We want to be able to represent a linked list as such. So the way I'm going to do that is actually, it's pretty clever, and it's hard to do. Representing a linked list is not an easy task by any chance. So I'm just kind of going to spoil it. But basically, what we're going to do is, at the end of the day, we want to get something that looks like this, right? We want to get a string that looks like it has parentheses around it, and we want 2 elements in the string, the first and the rest. So I'm going to take the idea, basically take 0, and then 1, and I want to have some way to format, and I'm going to format it with the self.first, which is going to be a number. Now, what we can do is we can't really format an object, so I need a way to represent the rest of the rest of the linked list of the string. So I'm going to call that rest_, okay? And so what I'm going to do is I'm going to build up this rest_, initially. So I'm kind of going backwards here, but this is, I think, the most easy way to think about it. And so if it's the case that I'm only worrying about repr for non-empty linked lists, because the empty linked list is just going to be on empty tuple, which is good enough. So for non-empty linked lists, I just have to check if my self.rest is empty, link.empty. What this basically means is I only have one element. So to do this, I can just make my rest string an empty string, because there's nothing else in the rest. Okay? And otherwise, what I can do is I can make my rest string. So what the rest string has to be, it has to also compose of commas. So I first have to have a comma, and then this is the hard part to see, I can just basically represent the rest of the linked list. So this is the key idea here. So it's okay if you didn't understand that. That's a little more advanced linked list processing, more of a challenge question, but now let's see how it works. So if I type in link, I get link 1, link 2, and link 3. Okay, so now that we've built our entire linked list class, it's a pretty hefty definition because we have all these built-in methods that we want. I want to now go into inserting into a linked list.